Hey everyone. All right. Welcome back to a new class on IT-140. This time we are going to be studying conditional statements. Conditional statements are exactly what they seem like. They test whether or not a condition is true. It's basically becomes an if-else statement. If this is true, do this bit of code. Otherwise, do this other bit of code. So, they're very straightforward. Before we actually get into the conditional statements, though, we're going to have to learn a little bit of background information. And we're going to learn about different operators, mostly mathematical operators and things like that. This will actually be almost like a quick review of most of your math classes in high school, or at least the early ones. So you should see a lot of stuff that you've at least seen before in this kind of thing. So let's go ahead and jump into it. We're going to learn about operators. Operators are things that operate on typically two pieces of data, two variables, two values, things along those lines. The plus sign is an operator. When you're doing math, addition is an operator, multiplication, division, subtraction. We'll learn a couple of other operators like modulus and exponent and things like that. So let's go ahead and start looking at the different arithmetic operators that we have here. We'll go through this kind of quickly because they're really obvious. As you can see here, I've got the split screen again. So on the left-hand side, I've got my workspace, and on the right-hand side, I've got the guide that I'm going to walk through. Remember, if we want to get Python going, it's going to be Python 3 here at the command line at the terminal. Type Python 3, and there we are. We've got Python running. You can see we've got the three little greater than signs there that let us know that we are in the Python interpreter. And from here, we can just do some really simple stuff. We can do 5 plus 5. That'll come back as 10. 10 minus 2 comes back as 8. And this is basically just using the Python interpreter as a quick calculator. Multiplication. If you've never done multiplication on a computer before, instead of the X, you actually use the asterisk, which on most keyboards is the Shift 8. So look right around the 8 key and you should see it. So 5 times 4 is going to come back as 20. And then division is the forward slash. So there are two slashes on the keyboard. This is the forward slash. Typically it's the one that shares a key with a question mark, probably close to the Shift key on the right hand side. So if you want to do 20 divided by 4, comes back as 5. Now you notice that one actually comes back as 5.0. Division always comes back as a floating point, so that's something to keep in mind. You may have to adjust if you don't really want it to be a floating point. If you want it to be an integer, we're about to look at some things you can do to make that happen. But those are the first four operators, the kind of basic stuff. The next one we're going to skip ahead a little bit because all that stuff's pretty straightforward. We're going to skip to what's called the modulus. Now, modulus is it's actually used quite a bit in programming. There are a lot of different places where it becomes helpful. So the modulus, though, is basically when you do modulus division, what you get back is the remainder from the division. Typically, if you think of like long division, remember how you learned how to divide something like a small number into a larger number, and you had to do it with steps, especially if it was a more complex number. A lot of times you would start your division and then you get a remainder, right? So that's what modulus does. It actually just pulls back that remainder. The example here, I think, is a pretty good example. So if we click in the right spot here. So if we do 10 divided by 3, this is regular division, right? That forward slash. and we get back an answer of 3.333335. But if you do modulus division, and the modulus is the otherwise known as the percent sign, so just inside Python, the percent sign acts as the modulus divider. If we do 10 modulus 3, what we get back is 1. Now, we get back 1, if you think about it, 3 goes into 10 3 times, and you have a remainder of 1, right? So you get 3, 6, 9 are the 3 3s that go into 10, and then what's left over is the 1. If we do 11 modulus 3, we get back a remainder of 2, because 3 goes into 11 3 times with a remainder of 2. And you can see that if we do 11 divided by 3, we get 3.66666, all those 6's all the way up to 5. That's, that's what you would get if you do regular division, but if you do modular division or modulus division, then what you actually pull back is just the remainder. This, like I said, it's actually used quite a bit in various types of scenarios. We'll actually run into a couple as you move through the challenges. It's not something that happens every day by any means, but there are some instances where modulus division is really helpful. So we're going to touch on it this class, just mostly so you'll know that it exists, that it's a thing that you might need to do. But remember, that's what brings back the remainder. Now, if you want to just bring back the whole number part, then we call that floor division. And floor division is actually a double /. So if we do 10 double /3, we get back the 3. Remember earlier, if you did 10 divided by 3, you get back 3 and all the decimal points. Well, if you need it to not have the decimal points, you just need the whole number part of it. You can do 10 and then / floor division. And then that way you get back just the whole number. So if you do, if you needed to combine the two, you could do the floor division to get the whole number part, and then the modulus division to get the remainder, and put those together. And it's the same thing as just doing normal division. So those are some of the operators, the math operators that you're going to see. Oh, one more I forgot about here. Exponent. An exponent is when you raise something to another power. So you probably came across that in school. But if you raise 2 to the second power, or 2 squared, like that, you're going to get back 4. If you raise 2 to the third power, which is 2 times 2 times 2, then you'll get back 8. If you raise 3 to the fourth, you get back 81, which is 3 times 3 times 3 times 3. So that's an exponent. Now, I will say there is a challenge further along when we do some loops that will ask you to manually calculate an exponent. I will try to remind you, but you shouldn't actually be using this operator for that challenge, because that challenge needs to test some other skills. But when you're otherwise not trying to solve a problem for this class, you can absolutely use that exponent to get a number raised to another number. So that was a kind of a quick tour refresher of the different operators that you will see throughout this class, just different ways of doing math. And again, a lot of those will come in handy as we move on. We're now going to actually start looking at some of the actual comparisons that you'll have to do for conditionals. Now, remember at the beginning I said conditionals are basically, they test if a condition is true. And that's when you start using these comparison operators a little more. We wanted to draw out the comparison operators versus the math operators, because sometimes they can look kind of similar, especially with the equal sign. Remember earlier in last week we learned that the equal sign by itself is an assignment operator. So if you had a variable and you wanted to say my name equals, type in the right place, my name equals Derek, right? And you print my name, then it prints out Derek. That's because this equal sign right here, this single equal sign, is the assignment operator. It's a little unfortunate, but this happens a lot in almost every programming language. A lot of operators end up having double duty. So in this particular case, the equal sign by itself is the assignment operator, but as we can see over here on the comparisons chart, a double equal sign is to test whether the thing on the left-hand side is actually equal to the right thing on the right-hand side. So it's closer to the way you would use an equal sign in algebra. So hopefully hopefully you can keep those two straight. In this class, a single equal sign is assignment, and the double equal sign is a comparison. Now, all comparisons end up being either true or false. And remember, last week we learned about Booleans, and I said that they were either always true or always false. But even though they sounded kind of limited, they're actually really useful. We're going to start seeing how that use comes into play right now. First off, though, let's take a quick tour of these comparisons. Like the book says there, if you have 5 equals 10, what you get back from that is false, because what's on the left-hand side is not equal to what's on the right-hand side. So, but if you did 5 equals 5, it would come back as true. You could also do 5 equals 3 plus 2, and that comes back as true, because when Python's evaluating this statement, it's going to look on the left-hand side of the double equal of the comparison, and it's going to say, okay, well, I just have this value 5. And then it's going to look on the right-hand side and say, well, on the right-hand side, I have this little equation that I need to solve. I'm going to solve that equation before I make the comparison. So in this case, Python is actually adding 3 plus 2 together. It comes up to be 5 and says, okay, everything on the left-hand side matches everything on the right-hand side. So I'm going to say that this is true. And this is sort of the same way that all of these comparison operators work. If you look, the second one is 5 not equal to 10, and that's going to come back as true. In this case, the exclamation point stands for a not. If I can highlight it there. So that not equals, that is not equals to, right? That says, I want to take the left-hand side and verify that it does not equal the right-hand side, in which case this is true. It's true that 5 does not equal 10. And that's the thing about these comparison operators. Sometimes they can get a little confusing. You have to sort of think through a little bit, what exactly am I trying to figure out? Am I trying to figure out whether these things are true or whether these things are equal? If they're equal, then is this supposed to come back as true? Is it supposed to come back as false? You really sort of have to start thinking a little bit more about how you're actually using these things. So the greater than and less than operate the exact same way. Is 5 greater than 10? That's going to come back as false. Is 5 less than 10? That will come back as true. We also have greater than and equal to, so is 5 greater than or equal to 5? Oh, that's my fault. I put a space there when I didn't need one. There we go. 5 is greater than or equal to true. So this right here, when you see that, or when you see 5 less than or equal, sorry folks, I can't type. Let's try again. 5 less than or equal to 5. That'll also come back as true. Remember, this is greater than, or this is greater than or equal to, this is less than or equal to. Again, just sort of a refresher of some of the algebra that you probably learned in high school. So yeah, those are most of the operators that you're going to be using. Now, as you notice, these operators all set up a conditional statement. And that's what we're going to look at next. We're going to go to conditionals and start looking and seeing how those operate. Those are a little more complicated. So let's switch over from the terminal. We're actually going to open up a new file for the first time and see how that looks. Wait, actually one more quick operator. The logical operators and or. Those will come up quite a bit also throughout this course as we're dealing with conditionals and such. And is a way of comparing two values to see if they are both true, or is a way of comparing two values to see if either one of them is true. So if we have, we're just going to very quickly say true and false. True and false will come back as false, because for it to come back as true, both of them have to be true. True and true will come back as true. True and false will come back as false, because for the and, both of them have to be true. For or, only one of them has to be true. So true or false will come back as true. True or true will come back as true. False or false will come back as false. Now, remember, when I'm saying true and false here, that can also be anything else that that reduces to true or false. Or when we saw 5 equals 5 and 5 equals 10, that's going to come back as false. And look here, you can see how you can put these things together in sort of complex ways. Again, Python will sort of start in the middle and work its way out. It will evaluate the expression. It will go across and see, okay, I've got this double equal, so I need to compare what's on the left-hand side to what's on the right-hand side. And then I'm going to evaluate that. That's going to come out to be true. Moving along, I have an and here, so if I have an and, then that means I need to compare again what's on the left side of the and to what's on the right side of the and. We already know that what's on the left side of the and comes up to be true, and then it'll look and see what's on the right side of the and that comes up to be false. So the entire expression comes out to be false. So that's how logical operators work. There's actually, if you look, I don't know why they put it so far down. There's a truth table here near the end of this section, in section 23, that gives, this is actually definitely worth looking at. It's kind of a cheat sheet to logical operators. True and false is false. True and true is true. False and true is false. False and false is false. Same thing with or, all those various forms. And then we didn't actually look at not, but not falls into this. Not will negate something. So if it's not false, then it turns out to be true. And if it's not true, then of course it's false. So a lot of times you'll find a use to say something is not true, run this piece of code, something is true, run this other piece of code. So these truth tables are really good to look at to give you an idea of what all of how these operators work together, and a little bit of a cheat sheet. Now we are going to move on to looking at some of the other operators. Excuse me. Actually, we'll look real quick at membership operators, which is really just a way of saying, is something inside something else? Is this in that, pretty much? One way that you'll use this pretty straight off is by looking to see if a piece of a string is inside a larger string. So if we have the string Derek in the string Derek Pell, that's going to come back as true, because you can see on the left hand side we have that short string Derek inside the longer string Derek Pell. If we look for the string Derek inside the string IT-140, that's going to come back as false, because Derek is not in that string. And that'll work with pretty much anything. You can just say D in Derek. It doesn't have to be a full, it can just be one letter of a string, that type of thing. And of course the opposite also works. D not in Derek, and come back and say false, because D is in Derek. It's not in Derek. It gets very confusing. Look at the truth tables there. It's much easier to sort of look through all that and figure out how all of that fits together. In any case, the order of operation, definitely look over that to see how Python evaluates things in what order. It's just like you would have learned in math. Multiplication gets done before it. Multiplication and division will get done before addition and that type of thing. So operator precedence usually is not a big deal, but definitely give section 15 a glance so you can see what those conditions are. Right now, we are going to move over to conditional statements. Conditional statements are a little more complex, so let's just take a pause for a moment. I'm going to set things up. Actually, instead of pausing, I'll just show you how to do this. What we want to do, because conditional statements are a little more complex and they're not as easy to write on one line, it's definitely possible, but I think it makes more sense if you can see it laid out a little bit. So we are going to go, I closed out the terminal. I'm going to go File, New File, Conditional Test.py. That .py is very important. Anytime you create a Python file, it needs to have the .py extension. That way Python knows what you're trying to do, that it knows you're trying to create a file that is specifically for running Python. So we're going to create conditional test.py, and here we have a completely blank file. Like, this is the place where you can go in, you can do this yourself and create completely blank files and run some code samples. What we're going to do is we're going to type this code in. We're not going to copy and paste, because copy and paste does not give you the practice that you need. So you get to suffer through with me as I try to type this out. I'm not very good at typing, which seems a little ironic for a programmer, but it's true. So the first thing we're doing is we're setting a variable called torpedoes, and we're giving it the value of 0. Now, conditional statements are just if statements. If this thing is true, I want you to run this particular bit of code. So here we're going to say if torpedoes is greater than 1, Then we're going to print torpedoes launched. And then we're going to say torpedoes. Now this line right here, we didn't go over this, but you can look over it. It's in the further back in the book. This is basically saying it's a shortcutted version of torpedoes equals torpedoes minus 1, right? So here, this is the version that where you would take the variable torpedoes, take the existing variable torpedoes, subtract 1 from it, and assign that value back to the variable torpedoes. That's one way you can decrement or increment counts. You can reassign different values to the same variable. That's going to come in very handy further along. But this is a shortcut for it. This minus equals right there is a shortcutted way of saying, hey, take the whatever is in the variable torpedoes, subtract 1 from it, and assign that back to the variable torpedoes. This also works with the plus, with the division, with multiplication, all of that. So it's just a shortcut way. So right now, a couple of things you need to, I hope you see about this bit of code right here. On the first line, if torpedoes greater than 1 colon, right? So there are a couple of necessary parts to this. You start off with if. It is lowercase, so nothing here is capitalized. In the middle, you have to have some type of condition. This right here together represents a condition. If torpedoes, which in this case is 0, is greater than 1, this colon right there tells Python, I'm finished setting up my conditions, because you can set up very complex multiple conditions, and you need to tell Python that you're done so it knows to go on and evaluate the rest of your code. And you tell Python that with the colon. And so yeah, that's the first line, if, and then a condition, and then a colon. The second line, if you notice, it's indented a little bit. It's actually indented 2 spaces. This is the first time we've had to run into this. In the first chapter, it did mention that Python is an indented language. And what that means, if some of you have come from other languages that use curly braces to start and stop blocks of code, Python doesn't do that. Python uses indentation. So what this is saying is, if torpedoes is greater than 1, run all the code that's indented under here. So if we go here, right like that, when Python starts to go through this code, it's going to look at this first line and say, okay, is this condition true? If it is, I will print this bit of code. And then once I'm finished with this, I'm going to come out of the indentation and come back to the part that's completely to the left justified there. And I'm going to go ahead and print it no matter what, because it is not part of an indented block of code. So in order to get this file to run, we are going to go back quickly to the terminal. And for this, instead of typing Python 3 and going into the terminal or into the interpreter the way we did before, we're going to type Python 3, and then we're going to give it the file name. Right? That is the file that we have open over here, conditional tests.py. It's hard to see the whole name, but that's the name we gave it there. If you hover over it and click, you can see the name of the file, conditional tests.py. That's what you have to type right there. You're giving the Python interpreter the particular file name, and instead of going into the interpreter, it's just going to run that file. Now let's see what we get there. All we get is the word fini. And why is that? Well, let's go back and look. Our condition is if torpedoes we start off with torpedoes equal to 0, and then we check, are torpedoes greater than 1? Well, no, they're not. Torpedoes aren't greater than 1, so this code right here is never going to run. We can actually do something like this. Let's make it a little more obvious what we're doing. All right, so here we have, we've got an extra print statement here that tells us what our torpedo count is going to be. And because torpedoes is an integer here, we need to turn it into a string by using the string function. We talked about this a little bit last week, but now we're actually going to see it. We've made changes to this file. Codio saves your changes automatically for you, so you don't have to worry about saving them. We've made changes to the file. One of the shortcuts you can use in the terminal is you can just use the up arrow and it will run the previous command that you just typed in. So that way you don't have to type it in again. Python 3, conditional test. Now we see that torpedo count is 0. Well, that's because we started over here with 0. We don't see anything else because our condition isn't met. Now if we change this to 2, 2 of course is greater than 0. Go back over, or 2 is greater than 1. Go back over, run this code again, and we see both the torpedoes launched message, and we see that our torpedo count is now 1 when we started off with 2. That's because it has run both of these pieces of code. It's run both of these lines of code because our condition was true, and these pieces of code are indented, so that tells Python this is all the stuff I want you to run if this condition is true. Now, along with the if, we also have an else statement. Else doesn't require a condition. Else is like a default, right? If this is true, do these things, otherwise do this other thing, right? So it's just a binary condition. If one thing is true, run this bit of code, otherwise run this other piece of code. So it still needs the colon, and it still needs to have things indented. So what we'll do here is we will print no torpedoes and because our condition is true, in this case, we're going to have torpedoes are going to be 2. We will see that this second print statement won't run. All right, we go back over here, arrow up, run this again. We get the exact same results that we got before. The torpedoes launched and torpedo count is 1. You might be asking yourself, well, if torpedo count was 1 before, why is it still 1 now? Every time you run the file, Python starts at the top, it resets torpedoes to 2, and then does this conditional check and goes all the way down. If we go back here and set this back to 0 as we originally had it and run this file, we get the no torpedoes statement and a torpedo count of 0. If we look at that, you can see we are getting the no torpedoes because this if statement is not true. This if statement is false, so it does not print those 2 lines. It falls through to the else statement, and we'll end up printing that. And then, of course, it ends up printing the last line because the last line is not indented at all and is not in any of those blocks of code. It will print this last line regardless of the if-else statements. Now, there's one other conditional we can throw in there, which is called elif, or that's short for else if. Now, elif also needs to have a condition with it. It's like if, right? So if we want to say torpedoes equals 1, print last torpedo. So you can see here we have two different conditions. We have if the torpedoes are greater than 1, we'll do this bit of code. Else if the torpedoes are equal to 1, look at that, I made that mistake, equal to 1, then we'll print the last torpedo, then we'll print that this is the last torpedo, and we'll do this again. All right. So if torpedoes are equal to 1, we'll print out that it's the last torpedo. We will then decrement the torpedoes by 1 again and print out our final torpedo count. So with torpedoes equal to 1, we'll see over in the terminal that this is our last torpedo, and now that this bit of code is run, it is decremented to the torpedo. It has taken 1 away from it, so now we are back to having torpedo count of 0. Right? So those are conditional statements. Those are really powerful. You'll use those throughout pretty much every program you write anywhere, but especially in this course. Also, this is a really good way to practice. You can create your own file. You can throw any kind of code you want in it, and then run it here in the terminal. And that way you don't have to keep writing these little one-line programs. You can write, like more full verbose programs where it can do some more complex logic here to make some decisions. Earlier, though, I want to show you, I made this mistake. I used a single equal, which, as we learned, is an assignment, not an operator to compare. So what happens if we run this as it is now? This is Python telling you this is invalid syntax. This is not what you want it to be. The syntax for this should be elif and then some sort of conditional. But we haven't given it a conditional. We've given it an assignment operator. So Python's like, no, you're not doing something right. Go back, take another look. It's even telling you on what line you have a problem. And it's pointing, this little caret symbol right there is trying to point out to you, hey, this is where I think the problem is. It's not always exactly accurate. Python does its best guess to figure out what it thinks has gone wrong with your program, but it'll give you a little information there. But yeah, so we fixed it up. Go back, run it again. We're back to having a running program. So those are conditionals. Again, all conditionals are true falses. You can, that's pretty much an example, the example we just looked through right there. You can make complex conditionals, such as this example right here, where, let's get rid of this, homework equals false, and vegetables equals false. And then you can make conditionals that are if vegetables and homework, then print you deserve ice cream. We're just going to do if vegetable put your colon at the end there. And we're going to print, did you forget something? We're going to leave it right there to show you don't necessarily have to have an else. Most of the time you would probably want an else. As a default, it's sort of a catch-all. If none of the other conditions are true, then this is what I want you to do. But if we leave it like this for right now, we can go back over here, run the same thing. What did we do? If vegetables and homework, if vegetables and, oh, I know what's wrong. Nothing's printing because this first condition is false, right? Vegetables are false, homework is false, so that's false. That's not going to print. The second condition is vegetables and not homework. Well, vegetables is false, not homework becomes true, but because we have an and here, nothing prints, because remember, and has to be true on both sides of the and. If we change this to or, I believe we will see something print out here. There we go. Did you forget something? So you ate your vegetables or did your homework, then you should have done both, and did you forget something? So that's a really good example of how or and work very different, can give you very different results depending on what you're trying to do there. So kind of keep that in mind. Oh, let's see what else we've got here. You can nest conditionals. So we won't really have to go through this because I think it's pretty obvious. You can do if vegetables and you can, in any case, you can nest your conditionals like this. If Grace did her homework and did her chores and ate her vegetables, then Grace gets some ice cream. So it's the same type of thing where you can nest these if you have multiple conditionals where you have the first set of conditionals needs to be true, and if that's true, then another completely different set of conditionals also has to be evaluated, and you can nest those. When you nest them, I guess we will go over it real fast, because when you nest them, remember, it has to be indented, right? So let's add another variable here. What would we do? Chores equals true, right? We're going to start with that. If chores print, excellent. All right. So, any bets on whether or not this prints anything? I'm going to say no. And I was right. Because this first conditional is still not being met. Vegetables and homework still false. So we'll never get to the second conditional. Now, if we change this to true and we change this to true, now this first conditional will be met because both vegetables and homework are true. And then chores will also be true, and we should see excellent. There we go. All right, so that's how you would nest conditionals. Everything has to be indented. So you notice you have multiple levels of indentation. This is indented because of the conditional above it, and then the print statement is indented further because it has to be indented in relation to the conditional above it. So make sure you get your indentations right. That can be a real point of confusion. Let's see. Another thing that happens that you can do with conditionals is you can do things like this, where you might need to set up these really, really complex conditionals, right? So let's go and let's say apples equals 1, oranges equals 2. That is not how you spell oranges. How do you spell oranges? So let's say So let's try something else. Let's say here apples equals 1, pears equals 2, grapes equals 3. Now, if we wanted to make these more complex conditionals, we can say if apples greater than 0 and pears greater than 1 and grapes equal to 3, print fruit salad. All right, so you can see here what we've done is we've wrapped these inner conditionals in parentheses. When you wrap something in parentheses in programming, just like you do with math, it sort of sets that aside and says, okay, evaluate this on its own. Don't worry about anything outside these parentheses at first. Just evaluate this. This is going to evaluate to true. This will evaluate to true, and then this will evaluate to true. And then Python will come through and say true and true and true is all resolves to true. So we will print out our fruit salad. And I did it again. See, it's very easy to make this mistake. To make an assignment instead of a conditional. So let's try that again. There we go. We get a fruit salad. So this is how you can you can make these sort of complex conditionals and make sure that they don't accidentally bleed over into your other conditionals. You keep everything very separate by wrapping it in parentheses when you need to. We can also use conditional. You can use the in operator with conditionals. I think that should be pretty straightforward and obvious. You should definitely type in this code and play around with it and see what that does. And we talked kind of briefly about Boolean logic. That's what the truth table is here. So I think that's going to be it for this class. There's a few more things. Definitely make sure you read through everything in this chapter. And then once you start going into the challenge module, you'll have a little bit of a refresher, and then the challenges should start making sense for you there. Just make sure that with the challenges that you read them very carefully. Sometimes it can be a little confusing, but you want to read the challenge very carefully. Make sure you understand the challenge and then start trying to solve the problem. If you jump into typing too soon, you can really get yourself in a bad headspace. You can start going down a wrong path. You are much better off taking a lot of time figuring out the problem before you even start typing anything. Honestly, a general rule, even I've been doing this for several years. For the most part, I spend about 80% of my time thinking through a problem, taking notes, writing things down, making sure I understand what's going on, maybe typing a little bit, making a couple of experiments to see if if I can make one little part of it work, that sort of thing. But about 80% of my time is spent solving the problem, understanding the problem, and then the other 20% is writing the code to make it work. So make sure you're using your time efficiently. That's a pretty standard breakdown, and so you don't want to just jump straight into writing code, because that can actually be much more frustrating than taking the time to step back, evaluate the problem, figure out what's being asked, make a plan of attacking that problem, and then actually sitting and writing some code. Anyway, I hope this has been helpful. If you have any questions along the way, make sure you send me an email, and I will do my best to answer them for you. And I will see you next week.